PLA Plus, the revolution of higher mechanical properties of PLA, project of Engineer Dr. Muhammad Shahmi bin Muhammad Rasidi, Dr. Lokman bin Musa, Professor Madya Dr. Firuz binti Zainuddin, Nur Atikah binti Muhammad Rahim, Muhammad Nur Hakim bin Termizi. Since the 1950s, around 8.3 billion tons of plastic have been produced worldwide. 73% of beach litter worldwide is plastic. 90% of plastic polluting our ocean is carried by just 10 rivers. Plastic is killing more than 1.1 million birds and animals every year. Introduction. Polyethylene film is widely used in food packaging application. Since food packaging parts are always being used in daily life, this will make it abundant to the environment. It will create many problems to the environment due to the long time it needs to decompose. Problems. Recent concern over environmental impact caused by plastic waste disposal has motivated the need for green technology approach. Disposing of petroleum waste materials attract major attention regarding the sustainability issue and demanding continuous development of producing new biodegradable or fully biodegradable end products. In order to improve these problems, the use of PLA Plus is a viable alternative for replacing the synthetic packaging which is made from petroleum base. The scope of study. This project is to replace the polyethylene film that cause environmental problem and issue with the PLA Plus product that can help in decreasing the usage of petroleum waste material. The sample is subjected to scanning electron microscopy test, physical and characterization test. All the tests is needed to be carried out to determine each of the properties of this product to fulfill demands of market needs. Product introduction. A Plus is specifically designed to replace polyethylene film as a food packaging alternative. PLA Plus is fully biodegradable plastic and made from combination of jackfruit seed starch and oil palm based plasticizer. Product application. Mainly the application for this product is for packaging and medical application.
We are going to discover our raw material and our highlight procedure. For the first material, we use polylactic acid PLA in pellet form. As a solvent, we use chloroform to dissolve the polylactic acid. To produce porous PLA, we use sodium chloride NaCl as porogen agent. To enhance our porous PLA, we use polydimethylsiloxane PDMS. For the result, we are going to show the tensile test, SEM morphology, and also structural change of PLA plus from porous PLA. SEM morphology. For the neat PLA, it shows clear and clean surface that undergo brittle failure. For the porous PLA, it can be observed that NaCl content has been removed out from PLA matrix and left the PLA to become porous. For the PLA plus or modified PLA with presence of PDMS, it clearly shows that the surface of porous PLA were impregnated with pure PDMS. These have enhanced the surface to improve its mechanical properties. It can also be shown the siloxane crosslink samples exhibit smoother fracture and surface show pull out of siloxane. Characterization of PLA+. The effect of NaCl content on tensile strength of porous PLA and PLA plus show that the decrease in tensile strength when the NaCl content increased. The tensile strength of PLA plus was higher than porous PLA due to the effect of PDMS as toughening agent. According to Junhai Sai, 2015, in his study of fabrication of elastic porous PDMS cell scaffold, revealed that the tensile strength increased when the amount of porous increased. This happened due to the interconnectivity of PLA with PDMS. PDMS also helps in maintaining the structural and interconnectivity between matrix and the porous. The presence of PDMS decreases the effective cross-sectional area of the porous and make the PLA plus has higher tensile strength. Second, the effect of NaCl content on elongation at break of porous PLA and PLA plus. The trend of elongation at break decreased with the increasing of NaCl content for both porous and PLA plus. It was found that the porous greatly produced through leaching process of NaCl content. The elongation break of PLA plus are lower than the porous PLA due to high surface force energy, which make it elongate and fracture faster. Thus, increasing the amount of porous, the higher the surface force energy. A study by Li Zhu, 2015, stated in his study on synthesis and characterization of polysiloxane and acrylate elastomer material revealed that the elongation at break decreased when the amount of polysiloxane increased. This happened due to the formation of resistance in this stage interfered to elongation. Hence, the polysiloxane elastic property contribute by easy fracture after being stretched to some extent. Third, it showed the effect of NaCl content on modulus of elasticity of porous PLA and PLA plus. The modulus of elasticity of PLA plus increased when the NaCl content increased, while the modulus of elasticity of porous PLA decreased. The NaCl content greatly influenced the formation of pores. The increase in modulus of elasticity due to the pores that has been impregnated with PDMS and produce high interconnectivity between matrix and pores. According to Zizhen Wang, 2014, in his study on cross-link effect on PDMS elastic modulus revealed that increasing in the amount of PDMS increased the modulus of elasticity, which relate to the degree of cross-link. In addition, PDMS that impregnated in the PLA form increased the pores wall strength due to the properties of the PDMS, which were tough and influenced the modulus of elasticity.